But actually, I'm just going to go ahead and record this welcome session. So, yeah, you can go back and say, well, you said blah, blah, blah. I'm like, oh, yeah, you're right. Okay. So let's take a look at your syllabus. And I'll show you where you can get to this recording. It's from the eCompanion site. So what I gave you should look like this. You can see my contact information and my phone number and my email address. And so like if you're going to be gone, you don't have to tell me, but I do like that quick email so I kind of know what's up. Life happens. There are a lot of things more important than this class, but this class is pretty important because you paid for it. And a good thing that I am doing successfully now, I think, is recording lectures. So if you miss something, you know, go listen to the lecture and ask me for help. So we are going to meet in this room Monday, Wednesday, Friday. You can see my office hours are going to be Monday, Wednesday, Friday before this class, so not bad. Okay, and then you can catch me between classes from noon to about 1:30. I have a 2 o'clock. And then on Thursdays, we're going to have lab, but between, on Thursdays, you can catch me sometime too. I'm not usually on campus on Tuesdays, so, but if there's something going on, you know, I could do that. I do have two Twitter feeds, so I know it sounds kind of geeky. And I'm going to show you here in a minute how you can actually go to this Chem122 Twitter feed without enrolling in Twitter. You don't have to be a tweeter. And all my stuff is science. There's nothing like dramatic usually. So this one is really cool because the videos I said, you know, you can get them from this Twitter feed. And also, I'm also going to post like what's due when. So if you're like, Mrs. Snipes, I couldn't make it, what's due, I will go to the Twitter feed because I don't remember things very good. So there's that. So tomorrow we are going to be in room 512, an hour earlier than this, just because I think it's supposed to work in people's schedules better. Okay, so lab is it starts at 9 on Thursdays in room 512. And tomorrow we'll check in and you can kind of be thinking about if you know somebody you want to be partners with. If you don't, that's okay, we'll pair you up. So, okay. Now, I highlighted this right here because actually I have a comment about that. As you guys know, we're actually to the 5th edition, not the 4th. So I'm going to go ahead, and if you would, on your syllabi, go ahead and see if I can do this up here. Go ahead and cross out the 4th edition, and if you want to go ahead and write 5th edition, you can, because that's what we're using. So the other thing, and I see some spiral bound, okay, you'll need 2 spiral bound thingies. Oh, good. Looks like everybody's gotten them. Almost-ish. So what I did is, for those of you who don't have your spiral bound, we're going to take notes here in a minute. Just a few. And so this actually, when you buy your spiral bound notebook, this is what your notes are going to look like for the first few slides. Yeah, they were out for a while. Yeah.
They still are?
Yeah. So,
I've got both mine.
well, very good. And so you definitely will want these. If you've had a chance to look at what those look like, they have blanks in them. So like where it says chemistry, there's going to be, the slide's going to have the definition of chemistry, and you should either write it verbatim, what the slide says, or jot down in your own words. So, okay, that's how that'll work.
Is this actually where all of our notes are going to be?
Right. All of your notes are going to be in there, yeah. And another important thing is not just definitions, you know, maybe you know chemistry and matter. Those are kind of things that you have a preconceived notion of what the definition of those things are. But especially for, I'm going to be looking for you to write your problems in these, okay? So like when we do problems here, okay, write them down. If I go too fast, let me know. Or go ahead and watch the video afterwards. But, okay, it makes it work for you. If you just see me do it, you can't do the problems. So, and yes, there are problems in this class. Okay, so on with the syllabus. Okay, so you need of course, your textbook, you need the lecture spiral-bound notebook, and you also need a spiral thing for your lab manual. So in your lab manual are all the labs that we're going to do. And the cool thing about this class with lab is if you look at the end of a lab, that's where you're, I think at the end of the lab or throughout the lab, you're going to be filling in blanks there. My other chemistry class, they don't fill in blanks. They have to put it in a separate notebook and then afterwards take it home and write a report. You guys, you just bring your lab manual, you fill it out, I look at it, and you get credit. So it's kind of a sweet deal. Don't blow up the lab and we'll all be great. Okay. So we'll talk about more lab tomorrow, between now and tomorrow, I wouldn't run out and buy them, all right? But you are going to want, this is my favorite pair, you are going to want a pair of goggles. And the goggles can't be the cool ski-looking ones, you know. You don't want the tinted ones anyway. But they have to be kind of confined, snug to your face. Okay, so that's what these are. And these are two. They are indirectly vented. Of course, your eyes would get all sweaty if they didn't vent. But those little buttons there actually have a way for air to get in and out. So there are some that are similar to this, but they have holes, and those are directly vented, and those won't work. So I mentioned don't go out and buy some. You don't need any for tomorrow. But I'm going to have a box of these sitting out, so feel free to ravage. You'll also need a calculator. So I brought two calculators that both handle scientific notation. That's why they're called scientific calculators. So you know it can handle scientific notation if, and I'll kind of write it up here, if it has one of these keys. Okay, if it has an EE key, okay, the calculator's good. If it has an SCI key, the calculator will work. Or if it has an EXP key, okay? Any one of those three keys. And if you happen to find a calculator that has two of these keys, it's like finding a male calico. Okay. You're like, really? How'd they do that? Because each one of these will get you where you need to go with scientific notation. But it says you cannot use a programmable calculator, okay? And this, how you know it's a programmable calculator basically is the size of the display. They can graph stuff for you. And the graphing thing's not bad, it's just usually I can download an encyclopedia. And it gives an unfair advantage, obviously. Most people like me say, I don't know how to download an encyclopedia. Like, I know. But you can't use this. You can use it for homework. And this one, Dollar Tree, guess how much I paid? Yeah, $1. All right. So any questions about what you need? Okay, so far so good. All right. I'm not going to belabor too much about this course and the different units, other than to say there are 4 main units of material, and they're all wonderful. I think everybody should take chemistry, to know what happens on the small scale, So there will be a unit exam over each of the 4 units, and you notice that there's a 5th unit of material listed here in the syllabus, and if time allows, we'll talk about gases. That's what Unit 5 is, so we'll see. The 4 units will have an exam after each. You see the broad course goals, and actually Introduction to General Chemistry is kind of a standard course, so a lot of times it replaces or can very much supplement a high school chemistry course. 2 semesters, I do it in kind of 1 semester, what they do in 2 semesters at high school. Okay, so your assessment, you can see that you're going to have homework, you're going to have those unit exams I talked about, and then the lab component. Honestly, if you're here for lab and it looks pretty good when you leave, you're going to get an A in lab, and that's 25% of your course grade, so, right? So under student assessment, it talks about, it talks about, I'm supposed to tell you if I'm going to give extra credit, and I don't generally give extra credit, but I reserve the right to give extra credit. How's that for going out on a limb? Whatever, right? The thing is, if I give extra credit, it will just kind of, if you missed any homework, it'll kind of go into that pot. So attendance will take it every day, and if you miss a day, I will, you know, I'm not trying to be too much of a jerk about it, but I will kind of refer you to the Twitter, actually. You know, if you miss a day, you're like, well, what did we do? I'm like, well, did you check the Twitter feed, you know? I know not everybody has access to a computer. We can talk about that. Lecture, it's the usual, and I said maybe we should get up and do jumping jacks. I was kind of serious. This room gets kind of warm, and 50 minutes is a long time. Got the Mountain Dew, so I don't know. So try to be attentive and try to avoid the whole texting, although I know how that goes. Okay, so if you do have something serious going on that you need to text back and forth to somebody, probably it'll be distracting to maybe the class, so you probably need to take it outside. So that works. Okay, cheating. The only thing I run into, and it's not really, sometimes it's more not really trying to cheat, just working with somebody else, and you just, working with somebody else is not cheating, but just seeing them outside the 5 minutes before you come to class and copying their homework and turning it in as yours, that's cheating. So I think we'll be fine. I've never had it. I encourage people to work together. In fact, I know it's a small group, but we might see if there's a topic people are struggling with, we might see if there's a time when you guys can get together, or you guys want to get together and I'll be around, you know, study group sort of thing. There'll be 4 unit exams, and they run about, maybe after we've been here for 4 weeks or so, we'll have a test, that kind of thing. All teachers need to address what if a student can't make it to a test, okay? And the way I do that is I don't give makeup exams, okay? Let me know you're not here so I know you're not in a ditch dead somewhere, okay? But if you miss a test, what I'll do is when you take your final exam in May, that makes everybody smile. When you take your final in May, what I'll do is I'll take that percentage and substitute it in for your missed exam. Okay? But the other thing is if you take all 4 unit exams, which I hope everybody does, what I'll do in May after you take your final is I'll compare the percentage you earn on your final to your lowest unit exam. And if your final is higher, it'll count twice. It'll be substituted in for your low unit exam. So, yeah, it's kind of a lifeline. And, so one thing about the tests, though, because I see a few of you that I've had in my meteorology and astronomy, is the tests aren't multiple choice. Okay, they are short answer and some problems and some definitions. But for the tests, I will kind of give you, I'll give you an outline before the test, the topics and stuff, so. And, so I told you I have a Twitter feed, the Chem122 Twitter feed. If you go there right now, and I'm going to go there in a minute, you actually can see the end of spring 2014. So it's conceivable, and I go over my tests and I record them, it's conceivable you could go backwards in my Twitter feed and look at old tests. That's up to you, you know. Kind of an interesting thought. Okay, so that's tests, assignments. So chapter assignments are chapter assignments, and those will be due the next lecture day. Okay. And this says that actually in your notes, the packet, the spiral bound thing for your notes, at the beginning, the first page for Unit 1 is called a lecture guide, and there are extra problems you can work if you want to. Geek as we are. All right. Lecture guide problems, that's what I just said. Laboratory, we'll be meeting there tomorrow, room 512, 9 a.m., not 10 a.m. Okay, and we'll kind of talk a little bit about the lab here in a minute. All right, so the eCompanion site, I'm just going to go ahead and take you there. Okay, first off, how many people have used eCompanion in here? All right. So I'm going to show you these days. It used to be harder, but these days it's pretty easy. This is SEC's homepage. So the deal is if you are using a computer here at school, it already knows who you are as an SEC student. So if that's the case, you can go ahead and go to HawkNet, and it will take you to where you can get to eCollege. Now, if I was at home, I'd go to HawkNet and be like, who the heck are you? So I'd have to tell it my SEC ID and my SEC password. So as it is, it's going to go right where I need it to go because it knows me. So if you want to go to your eCompanion site, this is where you need to go. Online class, okay? And what I use eCompanion for, well, now I use it to, the Twitter feed I keep talking about, actually, you can get it from here. You can see it's like a scrolling thing there. But I also use eCompanion. I started using it for grades, so we can all kind of see where you're at for grades. And also, if I want to post an answer key to exams or post answer keys to chapter assignments. Okay, so you guys are here. You can see the other things I'm teaching, the other chemistry and meteorology in the spring. Okay, mine's going to look a little different because I'm the author of this eCompanion site. So you guys won't see author tab. And you guys also won't see other things that have asterisks next to them. You will see the Mahjong Chem, which is kind of fun. But here, this is called the course homepage, right? And so this is where you see the Twitter feed I was talking about. So you see where it says Welcome Spring 2015 semester? Okay, this is old stuff. So you're like, wait, Mole Day, what the heck? Well, that was from October, okay? So what I'm saying is if you scroll down, you can actually kind of keep going back in history, what I posted last spring. It's an interesting thought. Okay, so this column has some videos, YouTube videos. I'll probably kind of maybe edit it just a little bit so it's more pertinent to exactly what we're talking about now. And then this one is my science Twitter feed, which I just kind of randomly put up stuff. Isn't that pretty? Look at that. Can you see that little picture there? This came from the National Weather Service, or NOAA, and it's just an amazing picture of a sundog, and just awesome. Okay. Any questions about that? So when something's due, you're going to see it in this first column. It's going to say, you know, today's assignment, blah. A little posting. It's so easy for me. Easy's good. And you can subscribe to it if you want to. If you don't want to subscribe to it, that twitter.com/EA_Snipes_Chem122, that will take you here, okay? You could bookmark this. And this is the same, okay? So this would say your assignments and your videos and everything. Let's see. Doing okay for time. Any questions about the eCompanion? Okay, I think so. So I mentioned gradebook. Okay, actually, as far as I'm concerned, everybody has an A now. So you see your names listed here. Those little asterisks is where I'm going to put your 10 out of 10s. You can email your fellow people in this class or email me. Doc sharing is where I will post the answer keys. Okay. Also under doc sharing is my syllabus. So if you're like, oh, what's her syllabus? There you go, doc sharing. So that's about that for now. I think we were almost done with the syllabus. You're like, really? Yes. Okay. So keep me posted if there's any special needs, if there's anything I can do or need to know to make this a better semester for you. Okay. Here is the different parts of the course and how much it counts towards your overall grade. I mentioned labs show up, don't blow up, and you get a quarter of your grade. Okay, A. Okay, down here I do give pluses and minuses. And like I said in my syllabus, if your attendance and attitude is good, you know, if you're borderline, so like if you're, that would be a good example. If you're 88.3 even, I don't know, 88 point something, there's a possibility if it's been a good semester for you, you'll get the A minus. Yeah. So. But if your attendance has been, in your attitude for whatever is not so good, then you get the B plus. So let's see. I guess that last page is all about the lab. Okay, and I'll let you kind of read this. I'll point out a few things that I definitely want to draw your attention to. One thing, in case I don't say it, is lab is scheduled from 9 to 11. A lot of times it won't take 2 hours, okay? And if you need to leave or whatever from a lab, let me know and let your partner know, and we can work that out. Number 3 is kind of new for me. I kind of ran into a situation where sometimes students couldn't make it to class but wanted to make it to the Thursday's lab. And that almost gets kind of dangerous because a few things. You don't really know how to behave in the lab unless you've kind of heard some of the lectures. So you need to, if you haven't been for the 3 consecutive lecture periods before the Thursday lab, so I guess that would be Friday, Monday, Wednesday, right? You have to be there for one of those days, something like that. You need to, then you're eligible to work in lab. Okay, I think it all is kind of self-explanatory. No questions about that? Talks about being on time. If you're running late, hopefully it's not more than 10 minutes late, because more than 10 minutes late and you're also not eligible to get those lab points. Okay, so I know 9's early. Okay, there is another sheet though I need to give out, and it's just kind of an addendum to my syllabus, and it's going to look like this. There, it's going to look like that. So this is just kind of extra information, not associated with introduction to general chemistry, but just stuff everybody should know. One of the things coming up, I think under my information is I live in Burlington, so if the roads are bad, be sure and check the teachers not coming in. They're pretty good at canceling if the roads get bad. And also, if the roads are bad, they don't cancel, your teacher's gonna be here, but you think that you're jeopardizing your life to come to class, don't come to this class, okay? That would be a bad thing. Okay. I think that all kind of, it's good information to have. Any questions so far? Okay. Well, let's take a look at a few of the slides and see how this goes. Okay. So I'm looking forward to getting to know you guys, or a little better, or whatever, get to know you at all. But here's a little bit about me, kind of all in one shot. So my master's is in chemistry, kind of veering towards, there's a lot of branches of chemistry, but analytical chemistry. I got it from Western Illinois University, living in Burlington. So if you're a commuting person, I know what that feels like. So my undergraduate degree was from UNI, go Panthers, right? Both great schools. I do like to be outside, so that's kind of, it goes along with I enjoy teaching meteorology and astronomy, my other 2 classes. I play the French horn, and right now I'm in a couple of groups, but if you've ever heard of the Southeastern Iowa Symphony Orchestra, I play with that, I'm so excited. I'm 4th horn out of 4, but hey. And I cannot be bribed, but I really like chocolate, and we've got 3 children, only 1 at home now. So, and my husband also teaches for SCC. It's Carl Snipes. So, okay. So get your pens ready. And again, let me know if I go too fast or whatever. But definition-wise, chemistry is the study of cute little atoms. And as we know that those atoms come in different flavors, we call different elements. So we over here have a poster that has boxes with, and each box is a different element. Okay? So chemistry is a study of how atoms of those different elements, how they behave. How they combine, how they don't combine, okay? Of course, if they combine, we call those atoms that have combined together compounds. So matter is, by definition, anything that has mass and occupies space. So it's kind of fun when you, the particle physicists or the people who study physics just are kind of a different breed, I think, physicists. But when they start to talk about exotic particles that don't necessarily have mass, or exotic particles that don't occupy space, it's interesting. So, and seeing these two definitions reminds me that for your unit exam, a lot of times the first section will be definitions. So, and I usually give you the definition and ask for the word. So it's better than giving you the word and you define it. So my point is to prepare for a unit exam, I would look these over. Okay. All right. So just some everyday matter, a pop can. And I'm going to show you in a minute. It's hard to get a picture of an atom. So, of course, these little balls here are atoms, but it's a drawing. It's not a photograph. Okay. So atoms can be all the same, and we kind of see if you have a can made of aluminum, really that's what we call a homogeneous pure substance. All those little atoms are aluminum atoms. Okay. And if we compare that to if you have a bottle of some liquid, and in this case it's ethanol, okay, and in that case we see the repeating unit, the what is it, C2H, well, it's got carbon, hydrogen, and oxygen. You see those cute little repeating units of ethanol. Oh, excuse me, isopropanol. Oh, I'll just now, do you guys see that? That's like the caption is different than this is my problem. Ethyl alcohol, okay, isopropyl alcohol. Those are two different substances. So you're like, dude, which one is it? Oh, well. It's not for us to decide. But the point is, okay, carbon, hydrogen, oxygen in a repeating unit in a molecule. Okay. So I mentioned it's hard to really get a picture, like say cheese atoms, right? Get a picture of a group of atoms that are kind of bonded together in like an aluminum can. But we do, there are certain cool ways of getting that. And a scanning, tunneling microscope is one way to kind of trying to get the general shape of atoms connected together. And some of you guys might recognize the helix form in this, okay, DNA. We won't be doing this in lab. So one of the things I want to get to today is kind of a really everyday phenomenon of the three states of matter, the solid, liquid, and gas, okay? And we're going to pick on water just because water's so common. But everything, honestly, if you think about it, you're like, really? All substances can be a solid. All substances can, that same substance can be a liquid. That same substance can be a gas. It's interesting to think about how you get there. Okay, and usually, how do you make something from a solid to a liquid? Usually heat it, yeah, exactly. And how about get it from a liquid then to a gas? Add more hot, add more heat, exactly. So you can do that with all matter, which kind of is fun to think about, I think. So if we pick on water, water is notorious. The formula for water is H2O, exactly. So it has 2 hydrogens and 1 oxygen, and they are arranged kind of in a Mickey Mouse. So every time I see water molecule, I always think of Mickey Mouse. So there's oxygen, hydrogen, hydrogen. Now, if water is in its solid state, can you see where they're like ordered? That's kind of unusual with solids. Not all solids do that. Looks like you're kind of looking down a tunnel. So each one of these, I know it's hard to see. That would be the H2O you guys told me. Okay, so water in its solid state looks like that. Okay. Water in its gaseous state looks like this. Gas and vapor, they're the same thing. Water in its gaseous state looks like this. So now you can clearly see them. What else is different between these two?
The other ones are bouncing around a lot.
Yeah, they're all bouncing around a lot. How can you tell? Very good. They're bouncing around.
It's because with gas, all the atoms are faster and they're actually moving rather than in a solid state.
I don't know if you heard him, but in a gas, they're moving faster, and they're running. Yes, exactly. So these are fast little buggers. Okay, so what about a liquid then? What's different between a solid and a liquid?
Seems like the atoms aren't really in a uniform pattern as they were in the solid.
I like that. You're kind of saying they're random.
Yep.
Exactly. And this has lots of energy. And here in a minute I have a slide that says actually this has a lot of bonding. And we'll talk more about that bonding in this class. That's like the invisible glue that makes atoms stick together like that. Okay. All right. So now we get to this nice little matrix. You see solid, liquid, gas. Okay, and then we can talk about those 3 phases of matter in terms of some stuff. So let's pick on solid first. Now, when I talk about description, the 2 things I'm going to emphasize with description, and your textbook does this too, is when something's a solid, what does it do with regard to its size? And if something's a solid, what does it do with regard to its shape? And you can think of an ice cube if you want. If you put an ice cube in a beaker, okay, that ice cube's just going to sit there. Okay, so it's going to keep its size and it's going to keep its shape. What do you think about what it says degree? How much intermolecular bonds are there? Lots or none?
Lot.
Lots, exactly. That's all that means. So you can put lots or high. How about much motion? Once it's solid, very little. Yep. I almost think of them as they're so cold. They are low temperature, and they're too cold to move. Okay. So let's pick on a liquid. So let's say you take a cup of water and you pour it into a pitcher. Okay. Is its size going to change?
Not technically, but
What's going to
The
change?
amount won't change, but the size will
yeah.
mold to the container.
It will. So its shape will change. Exactly. And I think you guys were both saying the same
Yeah.
thing. Yep. So if you pour that cup of water into a pitcher, okay, the deal is it's going to flatten out to the size of the pitcher. Okay. So its shape is going to, what we say, conform to what you put it into. Thank goodness. I love that about liquids. So in that sense, its shape is indefinite, but it'll still be a cup. The volume will be the same. And then actually the next 2 boxes, I think for liquid, if you want to put moderate, you can. That's what I usually do. So how is it connected? Moderately compared to the solid and the gas. Okay, that would be the intermolecular bond. And how much energy does it have? Moderate amount of energy. I don't have intermediate up there, but same thing. It's kind of like Goldilocks and the 3 bears. The Papa Bear, the Mother Bear, and the Baby Bear. Okay, So gases, they are awesome. So what do you think, if you take a cup of air, you know, you have to, cup of air, okay? And then somehow transfer it, it has to be a vacuum over here into your pitcher, but somehow transfer that cup of air into your pitcher. What happens to its size? What about those gas particles?
Nothing, it has no size or shape.
Right, well, the size
Yeah.
will go to whatever container it
Yeah.
can. Yeah. So its size is like, hey dude, I'm gonna go ahead and fill this container, and the shape, I'm gonna go ahead and fill the container. So we say it has an indefinite size and indefinite shape. Gases are great. And actually that first one, your textbook has a figure coming up, and that is why gases, quite frankly, have a lot of blank space between them. That's why you can squeeze them or compress them. Gases are compressible. So how much bonding do those gas particles have? Lots or none? None, exactly. In fact, if the gas is behaving ideally, and actually there's a word, ideal gases, no bonds between gas particles. Okay, so how much kinetic energy? Lots or none? Lots. And if you're asked on a test and you go ahead and put lots of energy, same thing as I, okay? So, bunches, yeah, whatever. And sometimes, actually, you could almost draw a picture if I put this on your Unit 1 exam. Draw a picture. Speaking of, we have one of my favorite animations coming up. Okay. So this semester, I'm teaching General Chemistry 2, and we're going to start out with this whole how do atoms or molecules stick together to make solids or liquids or gases. What's in that intermolecular forces, that invisible glue, okay? In that second to last column, when you said high degree of intermolecular bonding in solids or no intermolecular bonding in gases, that's what we're talking about. So my point is, in General Chemistry 2, that's when we kind of dive into the nature of that more. But I just want to kind of tell you what's out there. So I mentioned one of my favorite animations. Sometimes, you know, when I'm trying to get to sleep, dumb things like this, if I've seen it recently, go through my mind. So I apologize in advance. And it's not much. It's kind of geeky. Okay. Oop, that wasn't it. It's the other one. I like that one too. Quite appropriate. Okay, so this just, you know, kind of summarizes, and I hope nobody's, avert your eyes if it makes you dizzy. So solid, liquid, and gas. It kind of shows the two things, kind of the degree of intermolecular bonds from lots of bonds to no bonds. It also shows the amount of energy that we actually, the energy associated with motion is called kinetic energy. So it's kinetic energy. Okay. And this is, like you were saying, kind of from left to right, if you add heat, right? Yeah. Solid, add heat to liquefy it. Liquid, add heat to vaporize it. Okay. So some of that heat goes into not only just thermal energy of the material, but kind of that kinetic energy. So, all right. Enough. Okay, so here's a figure from your textbook to kind of summarize kind of the matrix that I introduced. And I'll just put all these up here. You might see kind of the similarity. This, I like the first column because it actually kind of talks about the little nudging movement that solids have. Okay, we call that vibrational or oscillation, okay? Versus if a gas particle also has that, but it also has this translational, actually, is the word for that last movement. Translational motion. So it's funny how translational motion. That's kind of the side to side. Okay. That last column talks about if matter has a lot of space between it, which gases do, then you can take that matter and make it smaller and smaller. It's what we say compressible. And so gases are really compressible. Liquids and solids are generally what we say incompressible. All right. So, last little video here. Oop, that isn't what I wanted. Now this has sound. We'll see how our sound's working today.
Matter changes.
It's not.
Atoms and molecules are in.
This is the right thing.
Matter changes. Atoms and molecules are in constant motion. Heat increases this motion. The amount of motion dictates how well atoms and molecules can hold on to each other. The less motion there is, the better the hold, and the more solid the matter. When liquid water is cold enough, its molecules arrange in a particular structure and turn to ice. When heated, the vigorous motion of liquid water molecules separates them from one another, and they become an invisible gas.
I love that. They become an invisible gas. There's something almost poetic about that. Okay, so if you're looking at your PowerPoint slides, you see that the next slide is dun dun dun, an assignment slide. So I'm going to show you the eTextbook for this edition of TRO and show you kind of how doable these are. Okay, these are going to be due on Friday. This is Wednesday. These will be due Friday. Okay, so now I do drop 10% of your assignments. I don't take assignments late. I do take them early. So if you know you're not going to be here, turn them in early. But I do drop 10%. So that usually should kind of work for you. So this is what. Let's see if I got that right. So 1, 3, 4, and 7. So if you go at the end of, we're clear on chapter 3. If you go at the end of chapter 3, okay, you should see this. Okay, notice I don't have a page number. Now, I'm transitioning to the 5th edition. Just you aren't transitioning, but there might be a few places where the figures in your PowerPoint slides have the wrong page number. They don't match up exactly. That's the 4th, 5th edition sort of thing. But these are the questions you need to answer. Okay, or this is where you find them. Define matter and list some examples. You can do that, etc. Notice, like a lot of textbooks, the blue ones are the answers at the back of the book. Okay, so not too bad. Any questions about that? Okay, we'll see you all on tomorrow at 9.